Hello everyone, in the next 10 minutes I will give you a brief overview about our work, Shiftly, a novel origami shape-changing haptic device for virtual reality. This is a work by my colleague Hugo, Khrystyna Vasylevska, Hannes Kaufmann and by myself, Tobias Batik. Virtual reality is not limited to visual and auditory channels. Instead, the sense of touch can play an important role when we interact with those environments. Transforming VR from an audiovisual medium to a multisensory experience. While haptic feedback is not new to VR, it is still a challenge to provide realistic haptic feedback to the user's whole hands, especially when we want to simulate a wide range of surface geometries, including differently curved surfaces, flat surfaces, or different sharp edge features. Therefore, in this work we propose an encounter-type haptic device that aims to simulate the touching of virtual objects and surface geometries in VR. Our shape-shifting haptic device can provide haptic feedback for a variety of different surface geometries. It can shift its shape to form a tiltable flat touch surface, as well as different convex surfaces and varying sharp edges. The device uses only 3 actuators, combined with curved origami, keeping the mechanical complexity and the weight low. Ultimately, the device should be easily mountable to a robotic platform, for example as an end effector of an robotic arm. Here you can see Shiftly, the haptic device we proposed in our paper. On the left side, forming a cylindrical shape, and on the right side, forming a sharp edge. The device has a rigid prism-shaped frame. A curved origami is mounted on each side of the frame, forming a 360-degree shape display. Each side can be individually contracted and extended, folding and unfolding the curved origami. Each frame uses a stepper motor and a 2-gear gear system to initiate the contraction and extension of each side. The whole frame, including the gears, can be 3D printed. Additionally, we developed multiple attachment points and stands to mount Shiftly on a table or a robotic arm. So, how does the device actually create haptic feedback when the user interacts with a virtual object? On the left side you can see an illustration of the real world with the physical device Shiftly. On the right side you can see a representation of a virtual world that the user sees when wearing a head-mounted display. The user's hands are tracked and visually represented in VR. So first, the virtual object that the user is touching is selected. Then, the virtual object and the haptic device are partially aligned. Or more precisely, the point where the user is going to touch the virtual object and the point on Shiftly to which we direct the user's hand. While we align the physical and virtual objects, Shiftly shifts its physical shape to approximate the local geometry of the virtual object and the point where the user will touch it. Now, when the user is touching the virtual object, at the same time one touches a real object with equal or similar geometry, providing plausible haptic feedback to the user's hands and supporting the illusion that the user is touching the virtual object. To use the device in VR, it is essential that we keep track the position, rotation and shape of the device. But it's very unpractical to track the positions of all 3 edges as well as the center of the 3 origamis at any time. Therefore, we outline a kinematic model to compute those 6 points in space at any time. As input, we have to track a single point of Shiftly. This will be typically something like a wife tracker, and additionally we have to keep track on the extensions of each side of the frame. So basically the motor rotations. Based on that, the position and the geometric properties around these 6 points can be computed, including the approximated curvature of the origamis and the angles of the edges. Let's see how Shiftly can provide haptic feedback. On the left side, you can see the physical haptic device, and on the right side, a screen recording of our VR demo. First, Shiftly forms a sharp edge, now transforms in a curved surface, and by extending one side, forming a flat surface. Shiftly is also able to provide haptic feedback for animated surfaces. This is achieved by synchronizing the transformation of Shiftly with the virtual animation. We have evaluated our approach in 2 user studies. The first one was a study with a large sample set. We were interested in how realistic the haptic feedback that Shiftly provides is. In this study, participants had to touch 6 different shapes. The virtual shapes were visually rendered, and Shiftly provided haptic feedback when touching them. So the participants were able to see and feel those shapes. After they have lifted the hand, so they were no longer touching the device, they had to rate how realistic the haptic feedback was. In the second study, which we conducted in a controlled environment, we wanted to investigate the range of haptic feedback the device can produce. The participants wore a head-mounted display, so they couldn't see the haptic device. Participants were instructed to touch Shiftly. Visual indicators guided them on where to place their hand. After participants touched the device, they had to select from 23 different surfaces the surface closest to the one they had felt before. This process was repeated multiple times, whereas Shiftly changed its shape and therefore provided different haptic feedback. For example, Shiftly formed a curved surface, as you can see in the top right image. After the participant had touched the device, one had to select a surface that was closest to the one the participant had experienced. For example, a strongly curved surface, as you can see in the bottom right image. Coming to the results of our experiments. The first experiment showed that Shiftly can provide realistic haptic feedback for different shapes. The haptic feedback was perceived as realistic, especially in the case of shapes that could be closely approximated. We also tried out shapes that could not be fully approximated, because they included concave surfaces or small discrete steps. And even in this case, the haptic feedback was frequently rated as good. The second user study showed that Shiftly can render a variety of different shapes. Participants selected geometries that were close to the one we aimed to approximate, and therefore we assume that Shiftly can create precise haptic feedback for the tested shapes. Coming to the limitations of our work. So far, we have used thick coated paper for the origami. This works sufficient to evaluate and demonstrate our approach. But a different material will be needed for a more consumer-ready product. For example, a flexible plastic composite. For a better controllable experiment setup, we have evaluated Shiftly mounted on a table instead of an robotic arm. And so far, our approach uses predefined points the user can touch an object. 2 things that we plan to address in future work. Let me quickly summarize the content of our paper. we present the shape-shifting haptic device Shiftly. It's able to create rich haptic feedback, including plausible haptic feedback for different curved surfaces and edge features. And this is achieved by only using 3 actuators. We integrated the device in a VR environment and evaluated our approach in a user study with combined 168 participants. Thank you very much.